this, what we are creating one matrix for this particular purpose and identifying which test case will be covered by which item, and the existing test cases can also be used for this mapping. Fine, we are having a list of test cases because test engineers are having a lot of possibilities, and thus it permits to reusing the test cases. So this model is reusable based on existing test cases. Fine. So this matrix will help us in identifying the major test scenarios, identifying and reducing the redundant test cases. Very important thing, because sometimes what happen, we can create a lot number of test cases. So our generation of test cases should be very large enough so that each and everything may be addressed clearly. And second thing, it must be very small enough so that the different test cases must not overlap with each other. Okay. Then identifying the absence of a test case for particular objective and as a result of creating them. So we have already generalized and we have already created objective based on SRS and design documentation. So on the basis of this, we identify whether which objective is not addressed, and based on that non-addressable objective, we will create test case. Okay. Designing the test cases demands a prior analysis of the program at functional or structural level. Okay, so this is functional or structural level. Therefore, the tester who is designing the test cases must understand the case and sorry, not case. It is cause and effect. Okay, always cause and effect study. Cause and effect study. So if you are master of this, you can create a lot of research paper. Okay. Because from next semester, you are trying to go abroad. You are trying to fill your forms for different universities in abroad. For this purpose, you must have a publication, and which too, if it is Scopus index minimum, or if it is ESCI, this is also minimum, or SCI level. Okay, I will discuss later on. So your research paper is there, then it is very easy to get admission in good universities. Fine. So once you know how cause and effect study is done, you can automatically convert this case into research paper, and this research paper will publish in a specific journal. And then if it is published in Scopus Index journal or ESCI or SCI journal, then it is very helpful for you to study abroad or in India also. So, but very important thing is rule quoted by Suneo Yamura. Okay, there is only one rule in designing test cases. Okay, what is he has quoted? There is only one rule. Who has quoted? Let me put his name. Suneo Yamaura. Okay, it is. So he has quoted, there is only one rule in designing test cases. Cover all features, and this is cover all features but do not make too many test cases. But do not make many test cases. Why? Because we have already seen that when we use two numbers, which two is from 0 to 999, it will multiplied 1000 multiplied by 1000 different test cases are possible. If you are including so many, means a large list of test cases, it is very difficult to test all of them, and it is very difficult to create a software within the deadline. So this is very important. And there are some attributes related with good test cases. Like good test case is one that has been designed keeping in view the critical and high risk requirement in order to place a greater priority upon the provided added depth for testing the most important functions. Second thing is good test case should be designed such that there is high probability of finding an error. Okay. Third is test cases should not overlap to be redundant. Already told you, each test case should address a unique functionality, thereby not wasting the time and resources. Although it is sometimes possible to combine a series of tests into one test case, a good test case should be designed within the modular approach so that there is no complexity and it can be reused and recombined to execute various functional paths. We will see later on about this functional path. It also avoids masking of errors, okay, and duplication of test creation efforts. And finally, a successful test case is one that has highest probability of detecting an as yet undiscovered error. Okay, whatever errors we have not seen, if the test case is good, it is able to check all such errors. So this is our map items into test cases, and this mapping is very complex if number of test cases are very, very high. Now come to select test case design technique. So while designing test cases, there are two broad categories like black box and white box. Okay, and there are many other categories inside that. So black box test case design techniques generate test cases without knowing the internal working of the system. Okay, we just put the input and we are taking the output. There will be actually the techniques to design test cases are selected such that there is more coverage and system detects more bug. Fine. Now, so more bug is our focus. Now come to create test cases. So this is our fourth activity. Now come to fifth activity. What is our fifth activity? Create test cases and test data. So test data is very, very important. Okay. It is just like a data set. Data set in Python programming. Fine. So likewise, we will create the data set and it is tested and validated for different things. So because you are learning to this particular subject, so when you are using Python, you can easily understand what is the validation and what is the verification. So this is the fifth step to create test cases based on testing objective identified the test cases. Mention the objective under which a test case Okay. So data sets are created. The test cases mention the objective under which a test case being designed, the input required and expected output. While giving input specification, test data must also be chosen and specified with care, as this may lead to incorrect execution of test cases. So we are also having provision of not a number, okay, and like character and limited number of characters. So all these things will be designed accordingly, and we are introducing false data also, and it will check whether it is working correctly or not. Now, sixth step is to setting up the test environment and supporting tools. So the created actually this created test case, okay, needs some environment setting and tools. It may be applicable or not applicable. If it is applicable, then we need to set this thing. So details like hardware configuration, testers, interface, operating system, and manuals must be specified during this particular phase. So this is setup test environment and supporting tools. So this is configuration sort of thing. Then this is the final phase, okay, under test design. So this is creating test procedure specification. So this is a description of how the test cases will be run. It is in the form of sequenced step. This procedure is actually used by the tester at the time of execution of test cases. So it is, you can understand the hierarchy of the test design phase, which includes developing test objectives, identifying the test cases and creating their specification, and then developing test case procedure specification. Fine. So this is our final outcome of this test design. Now come to test execution, which involves test incident report. Incidents are the activities or exception test log when we have performed this tag, and then test summary report. So in this particular phase, all the test cases are executed, including verification and validation. We already discussed. Verification test cases are started at the end of each phase. Okay, verification at end of each phase. Okay, so this is verification. Each phase of what? SDLC. Fine. Validation test cases are started after completion of module. After completion of this module, after completion of this module, we will start validation. Okay, so verification will be done at the end of suppose this is beginning and this is end. So at the end of each phase of SDLC and after each completion of each module, we will start validation. Fine. So it is the decision of the test team to opt for automation or manual execution. So execution may be what kind of execution? Automated, semi-automated, and manual. Test results are documented in the test incident report. So it is documented. Okay. Test log and testing status or test summary report. So this is our diagram. So you can also, let me check whether table is not given. So like test execution levels are unit testing. Okay, unit testing for this purpose, developer is the responsible person. Developer is the responsible person. Then integration. In this integration level, testers and developers both are responsible. Testers and developers. Then system testing is there. So inside this system testing, tester and developer as well as end users are responsible, like beta testing, etc. And then acceptance testing. In acceptance testing, testers are there and end users, no developers. So now come to post execution or test review. Okay. After successful after successful test execution, post execution phase will be there. Bugs will be reported to the concerned developers. This phase is to analyze bug related issues and get feedback so that maximum numbers of bugs can be removed. This is primary goal of test activity done. Okay. So first thing is understanding the bug. The developer analyzes the bug reported and build an understanding of its whereabouts, then reproducing the bug. Okay. Then the tester confirms the bug by reproducing the bugs and the failures that exist. This is necessary to cross-check failures. However, some bugs are not reproducible, which increases the problems of developer. So this is already actually we have already discussed in previous slide also. Then analyzing the nature and cause of the bug. Again, yes. So after examining the failures of the bug, the developer starts debugging its symptoms and tracks back to the actual location of the error. Okay. And after fixing the bug, developer reports to the testing team. Already, actually, we have discussed here in this. Yes, here we have discussed the same thing, but we need to discuss in very detail. That's why it seems that we have already completed this portion. Okay. Then come to reliability analysis. It can be performed to establish whether the software meets the predefined reliability goal or not. If so, the product can be released and decision on release date can be taken. If not, then the time and resource required to reach the reliability goal are outlined. And then coverage analysis can be used as an alternative criteria to stop the testing. And overall defect analysis can identify risk areas and help focus our effort on quality improvement. So this is our complete post execution phase. Then software testing methodology already discussed, test metrics discussed, V life cycle model. Okay, so this we need to discuss actually, and we have already covered in my previous slide, but let me explain. So this is our V testing lifecycle model. Okay. What is inside that? So we have already discussed that the verification and validation phases are there. So in this V testing concept, as the development team attempt to implement the software, the testing team concurrently, okay, or parallelly start checking the software. When the project start, both the system development and the system testing process begin. The team that is developing the system being the system development process, and the team that is conducting the system test begins the planning and system test process. So in this model, you can see that both teams start at the same point using the same information. If there are risks, the tester develops a process to minimize or eliminate them. So here you can see that in this left arm of V, this is our V, and left arm of V, the development cycle is progressing, and on the right arm, the corresponding testing stages are moving, okay, parallelly. So this is the V and V process, or you can say it involves verification of every step of SDLC, all verification activities, okay, and validation of verified system. So what we have already discussed, that it will performed at the end of each phase of SDLC. Fine. End of each phase of SDLC, and that is verification. And then validation is after each module. Fine. So here unit testing is there in the validation activities. Let us discuss validation activities. What are the validation activities? So this is unit testing. It is major validation effort performed on the smallest module of the system. Unit means there are multiple units. Okay, multiple functions are there, and if we use this particular function or any particular function, then it is known as unit testing. If avoided, many bugs become latent bugs and are released to the customer. Fine. Unit testing is a basic level of testing which cannot be overlooked. It is very, very important and confirms the behavior of single module according to functional specification. Then come to integration. So multiple units are there. It is a validation technique which combines all unit tested module. Okay, it must be tested. So testers, I am showing with the boxes. These are the modules and these are the tested modules. Then these tested modules, okay, and performs a test on aggregation or integration. You can also think that when we have tested all modules in unit testing, so where is the need to test them aggregation? So this is the answer for this particular question is interfacing. Okay. Unit modules are not independent and they are related to each other by interface specification. So if output of this will be taken by this and output of this will be taken by this and this too. Okay. Likewise, these are integrated appropriately, which will in means conjunction with other modules and so on. So how do we integrate the units together? So it is a random process or not? It is actually a systematic technique. You can very easily understand that if we are randomly integrating the module, it will definitely create a hazardous situation. So interfacing among modules is represented by the system design, and we integrate the unit according to the design and availability of unit. Therefore, the tester must be aware of the system design. Then come to system testing. So unit testing is done, integration is also done, and then system testing. Okay. This testing level focuses on testing the entire integrated system. It incorporates many types of testing as the full system. Okay, this is integration, and after integration testing pass, we have already seen that what are the levels. So unit testing is done by developer. Integration testing is together with the help of tester. System testing, tester, developer, and end users are involved. So end users now involved in this process. So validity of system or validity of whole system is checked against the requirement of a specification. So we have done this unit testing, integration testing, functions or different modules, system testing, and the acceptance testing is after system is completed, then tester and the end user both will determine the acceptance of this system. Actually, system is passed. Once the system is passed, it means SRS document is validated, and that's why now acceptance means whenever end users wants training. Okay, so there are quality testers are available who train the end user how to enter the system, how to go inside that. So this is coming under acceptance. Once the system is thoroughly understood by the end user, then it is accepted by the user, and finally the acceptance testing will completed. Testing tactics. So here testing tactics are a way to perform various types of testing. This can be done in manual testing and automated testing manner. Manual testing is the type of testing performed when the technique is applied manually. There is no automation tool used. And on the other hand, automated testing is performed with the help of testing to save the time to automate the test cases. Sometimes the testers may need to write set of routines for this. So in this, there is comparison between manual and automated testing. This can be asked in examination also. So manual testing is the type of testing which is done manually without using any tool. Whereas in automated testing, it is done with the help of automated testing tools. In this testing, there is no need of programming, and in this type of testing, programming knowledge is required. It is low quality testing and less reliable. It is high quality testing and more reliable. Why? Because it is surpassed by the user's eye. Okay, user's eyes are there, and this is a lot number of test cases automatically tested by the machine or the program. So that's why it is less reliable. It gives less accurate result and it gives more accurate result. As the test cases are executed manually, manual testing requires more testers. While test cases is executed using automated tools, less number of testers are required. It follows sequential execution process. It done on different machines by different automation tools at the same times or parallel. It takes a lot of time and it takes less time. So automated testing is a very good kind of testing, but tools are costlier. So there are different examples also in this testing tactics, like actual method for designing test cases, that is software testing techniques. Implement test cases on the software, and these techniques can be characterized into static testing and dynamic testing. So what is static testing? It is a technique for assessing. Okay, it is a technique for assessing the structural characteristic of the source code, design specification, or any notational representation, whatever notations we have given, that conforms a well-defined syntactic rules. Yes, you can say that syntactic rules. Okay, static is associated with syntactic. It is called the static because we never execute the code in this technique. Then come to dynamic. In this technique, the code is run on a number of input provided by a user and corresponding results are checked. This type of testing is further divided into black box and white box testing. So let us compare static testing and dynamic testing. So in this static testing, the code is not executed. Dynamic testing, code is always executed. It is here for a review and examine the software, and it is here for testing the software. Cost of the product is reduced as it always starts early in the software testing life cycle. This testing increases the cost of project as it is started later. Static testing is done as a phase of verification. Okay, phase of verification. Dynamic testing is done as a phase of validation. So again, just remember this. This is and in this and verification will start, and after the whole module is completed, the validation is started. So the outcome of static testing is dynamic testing. Static testing techniques are formal technique review, inspection, walkthrough. In dynamic testing, various techniques like white box and black box are used. Then it does not take time as its purpose is to check the item only. It takes time because it executes the software code and we need to run test cases. Now come to black box and white box testing. Already learned in your previous semester as a software engineering subject. This is also called as internal structural testing technique. So it is glass box testing. Okay, white box is also known as glass box technique. It is testing technique in which everything like code, internal structure of the program being tested is hidden to the tester. It is not known to the tester. While in this white box testing, it is a testing technique in which the code and internal structure of the program being tested must be known to the tester. It is done by independent software tester and it is done by software developer. Very important thing. White box is done by developer because he knows the code and all other things. And the tester does not knows the coding. So that's why it is done by independent software tester. This technique requires no programming knowledge, where in this white box programming knowledge is very important. So with this, we finish the second unit portion. And if you have any doubt, you can ask. Any doubt?
No, sir.
Okay,
No,
fine.
sir.
Fine, fine. Thank you.
No, sir.
So I had downloaded the attendance and then we will start on Monday with new topic. So thank you very much. Have a nice day. Have a nice time. Bye bye. Take care.
Thank you, sir.
Thank
Thank you,
you. Thank
sir.
you. Thank you.